Did you work through these names? Did you have time to do it? Hopefully you did. Let's break this down. So I'm going to just break apart the whole formula just so we can see what it consists of and then how we can name it. Okay, so we see for one that all of these have counter ions. So my complex ion exists in the bracket. Okay, so I'm going to write complex ion. Okay, so the counter ion in this case is 2 chlorides. So if I were breaking this apart now, then I know that this is separated as my nickel central metal with my 6 ammonia ligands. And now we can see there's 2 chloride counter ions. So that would be 2 Cl minus. So that means this whole thing has to be 2 plus. If it's not clear to you how I got that, stop, review, make sure you understand it. So the complex ion is in brackets. And so because it's listed first, we know that it's got to be the cation. We always list cations first. My chloride is outside of the brackets. So that's the counter ion, which we know has to be an anion. Cl2 means 2Cl minus, right? And so because this is a neutral compound, the whole complex ion has to be 2 plus to balance those 2 chlorides, all right? So now we can name this thing, and we recognize that it's got 6 ammonias, so that's going to be hexaamine, 2 A's, 2 N's, it's a mouthful, hexaamine, and then that's nickel, if I could spell. So that's nickel. And then now we remember each amine is 0 charge. So the amines don't contribute to the charge. So that 2 plus is entirely on the nickel. So hexamine, nickel 2, chloride. We have to remember the chloride is the counter ion. Okay, so now let's do this one. So now we can see that the complex ion is an anion because it's listed second. And if I were to break this down, we see K3, so that means 3K plus my iron central metal, my 6 cyanides, and then now I have to recognize that this whole thing is 3 minus because I had 3 individual K pluses. Okay, so now when I name this, I list the cation first. So that's just going to be potassium. So potassium, and then now the name of the complex ion, which we did already, but let's just make sure that we know this one. So there's 6 cyanides. So that's hexacyano. And then now this is an iron with a negative charge. And we also recognize this has to be iron 3 plus because there's 6 CN1 minuses. So that has to be 3 plus to give us 3 minus altogether. So that's hexacyanoferrate 3. Potassium hexacyanoferrate 3 is the name of this whole compound. Okay, so this last one now. So once again, we see the complex ion is in brackets, and it's listed as the cation. So we know that one is going to have a positive charge. So it's got a cobalt with 5 ammonias and 1 water. And we can see it's paired up with 2 bromides, each being negatively charged. So that means this has to be plus 2. And then now we can see we've got 1 water, 5 amines. The amine comes first, alphabetical order. So that goes pentaamine, 5 amines, pentamine, aqua, cobalt, 2 bromide. Okay? It's a mouthful. And then the last one I want to do is back to this Prussian blue because this whole thing is really complicated. but that's okay. We can do it. So we recognize the first cation is iron, and specifically that's an iron 3. So I would first start by saying iron 3. And then now we've got 6 cyanides. So that's going to be hexa, cyano, ferrate 2. So this whole Prussian blue, the actual chemical formula is going to be iron 3 hexacyanoferrate 2 is Prussian blue. All right, folks, so practice those nomenclatures. You are responsible for knowing how to name these compounds. Either come up with a name if you were given a formula, or come up with a formula if you were given a name. I'll remind you, of course, I do multiple choice exams, so you're not going to have to worry so much about spelling, right? The correct answer is on the page. But all the same, I do want you to be able to name these complex ions. All right, folks, I'll see you in the next one.